Good afternoon, everybody, and welcome at the first session of the GSD Ideas Summer Educational Series that is focused on Idea Statica, as always. And today we would like to focus on parametric templates to follow up on the recent development in Idea Statica. Parametric templates are an easy way how to design connection with just a few clicks and save dozens, if not more, minutes on your whole connection design process. So let me get the right screen. All right. As you probably expect, and as you can see, it's three presenters from GSD Idea as always, and this is the past webinars. Myself, Jan Barta. With me, I have Rose, our product engineer. How are you doing, Rose?
I'm good, Jan. Hello, everyone.
Hello, good to have you. And we have also a second product engineer in our team, Venkatesh. Venki, how's it going?
It's going good, Jan. And hello, all.
Perfect. Good to have you. Okay, a bit of instructions about the platform that we're using. So we switched in the last webinar to the Demio, which we're happy to use. The organization of chat and polls is a little bit different that you're used to from a GoToWebinar. So if you want to chat with us, do so in the right-hand corner in the chat panel. And just right next to it, there's a poll tab. So switch to the poll whenever you are asked, whenever we launch a poll. We will actually have one today in this session. And now what we have prepared in terms of the content. So first, the whole today will be about parametric templates, obviously. So we will be speaking at first about the current situation, how structural engineers model / design connections, and then go deeper into what, why, and how parametric templates should be used. This part will be covered by Rose. Then we'll switch to Venki, who will show us a live demonstration, some tips and tricks, and in the end, we will just summarize it, run some numbers, comparison between the manual way and the parametrical way, and have a Q&A session at the end, as always. If you want, you can place your questions in the chat panel on the go, but we will be answering what we will be able to answer during the webinar. We will do, but if not, we will answer the questions in the end as well. Now a little intermezzo between before we get to the parametric templates. Just a quick summary of how Idea Statica helps structural engineers today. Everybody knows Idea Statica for a complex connection, so this is obviously one of the most strongest use case where Idea Statica shines. If you missed our last webinar in June, watch the recording. It's available on GSD webpage. This webinar was dedicated to something what we call everyday connections. Those tens, dozens, even more of simple everyday connections that are on every project. They're covered in Excel spreadsheets or RAM connections, limcon, typically procon, but the comparison and the time savings with Idea Statica, this is what we covered last time, and I think a lot of you would be very surprised how much effectivity can be brought to this process. Anchoring as another use case where Idea Statica saves a lot of time, hours at least, on calculating the base plate, typically on the edge of the concrete block. Yeah, this is the place where anchor checks fail. Pure concrete solution for discontinuities. If you have on your project openings in beams, windows in walls, haunches, pier caps, pile caps, coupling beams, even all those idea statica calculates very fast, very easy. Uh, Member stability, another very time consuming issue, and also very difficult to calculate without idea statica, since the global FEA typically covers the global backlink, while the local backlink needs to be covered in some other software. So one of those softwares can be idea statica, and again, keep you on the safe side and save hours. And all those use cases, idea statica covers into bin workflows to make sure that you can streamline the whole process and the data exchange. With idea statica fully implemented, you can expect saving around 23% of the time of the whole project. If you're looking into material savings, there's a way how to optimize your design as well. Average saving using idea statica is around 8%, depending on the project, obviously. And with idea statica, you're sure that you're always on the safe side. So thanks for going with me through this summary of how idea statica helps. And now we can um, open and dig deeper into the parametric templates. I will hand over to Rose. Rose, please take the presenter.
Yes, thank you so much, Jan. I'm going to share my screen. Could you please confirm if my screen is visible, Jan?
Yes, all good. Thank you, Rose. Go ahead. Before you go, let's close our cameras so we don't disturb and our listeners can focus on the content. Thank you.
Right, thank you so much. All right, everybody, let's kick it off with the quick reality check with a poll, as always. Now, the question is here: what's your biggest pain point when it comes to connection modeling? I'm going to launch the poll right now. So you can see the poll on the right hand side of the Demio platform, wherein you saw it last time as well. Please cast your vote so that we get to know what exactly is the biggest pain point when it comes to the connection part. I know most of us would want to tick all four boxes, but pick the one that hits the hardest. All right, I can see that there are the answer. There are polls for all three options right now. Okay, all four now. Right. Okay. Thank you so much, everybody, for voting it. Quite no surprise. The time-consuming updates across multiple connection and the repetitive setup. Quite as I've mentioned, it's no surprise because uh, we have had a discussion. Me and Vicky, we have had a discussion about this, and then uh, we were competing over which would come first, and then we understood that all these points, all these questions would be at some point of time your pain point in connection modeling. So not to worry about it. Whatever your pain is with parametric templates and idea statica, this can be tackled. Now we'll see how idea templates can take that off your plate. Now I'm going to divide my session into four parts where I'd be discussing where we stand today in our connection design setup. What are parametric templates? Why do we need parametric templates in the first place? And finally, how do we do it? That's how I have planned my theoretical setup, and followed by the demo, which is done by Venki. Now, starting with the status quo, where do we stand today? And as as we can see, for every new connection, even if it's a slight variation or something that we have already done, we are usually rebuilding the model from scratch. Now that's easily 20 to 30 minutes per connection every single time, but multiply that across dozens or hundreds of joints in a project, and hours would add up really fast. And on top of that, we are often relying on the manual edits. Now that is changing dimensions, shifting plates, adjusting wells, and that introduces a lot of risk as well. And not to mention the typos, missed updates, version drifts, etc. And because of this repetition, most of engineers, including you, me, and all of us, barely have the mental headspace that is left for design checks, uh, which will also count for value engineering or to try out new ideas. And it becomes more about getting it done than improving the connection task. So that's a status quo. It works, but it's far from efficient, and that's exactly what we are going to change with the parametric templates. Now, let's start with what exactly is a parametric template. You can think of it as a smart, a reusable design model. Now, to put it in very simple terms, instead of creating a single connection from scratch every time, you build it once. It's like a basic version, and then you change the details that you need, like the beam length, the plate size, or bolt positions, etc. It's like having a flexible connection recipe, that's what we call, and you tweak a few values, and the rest of the connection components, all the rest of the connection components adjust to it automatically. And the model knows how everything is connected so that it updates correctly without any extra work from the designer's end. Now, to talk more about this, we need to know what are parameters. Now, the key to all of this, what I'm speaking, is called parameters. Now, these are just the values, or maybe we can call them as rules that control different parts of the model, like dimensions, positions, as already mentioned. Now, when you change a parameter, IdeaStatica automatically updates the model based on how those parts relate to each other. Now, if I want to say this as a real life example, uh, the question, how can this be applied in real life? Let's say a senior designer sets up a parametric template for a simple beam to column connection. They define parts that should be adjustable, or maybe that is adjustable, maybe the section size, bolt size, edge distance, etc. Now, when a junior engineer needs to modify the same connection in the same or in any other project, they don't have to recreate it. They just open the template, update the inputs, and then the model is almost ready. Now, why do we use them? Saves a lot of time and repetitive work that we have been already doing. Uh, Reduction of errors, since the logic is already built in, there is a tendency for us to reduce the errors. Keep the designs consistent across the whole team or company, because there is a setup where we can publish the connections. And in the end, make testing different options or exploring connections really easy. And the best part is that you can even link them with different tools like Excel or Grasshopper to push your automation further. Now, a quick tip on something. Now, parametric templates are very easy to spot in IdeaStatica library. You could see, as you can see in the image, you could see them marked with a small lowercase p symbol. So when you're browsing, you will know immediately which one is the flexible and which one is the editable one. Now, uh, to our further questions, why to use parametric templates? The first reason to use a parametric template is that it easy to use. Applaud it and apply the parametric templates. Now, I'd like to walk you through how simple the entire design process using parametric template here is. The first step is to create the model with parameters. Now, we start with the developer mode. This is where we built our steel connection, just like any normal connection, but with one key different. Here we use the parameters. Now, as we know, parameter is a variable that controls the part of the model, like the thickness, plate length, or bolt spacing, etc. Now, instead of entering fixed values, we link these features to parameters. That way, we reuse the templates later, and we only need to update or input those parameter values, and the model readjusts automatically. Now, coming to the second step, it is to upload the template. That is, once the model setup is completely done, we go to the publish function in IdeaStatica. Now here we upload the template to either our personal or connection the company connection design set. Personal set, as you know, it's only visible to you. It's a private set. Company set is shared within your team, which is great for standardizing typical connection when it comes to the teamwork. And the third step is to apply the template using the propose tab when later on we are working on another project. IdeaStatica is smart enough to detect similar connection geometry, so it will automatically suggest or propose the relevant templates from your library that match your connection geometry. For this, all we have to do is just select the template, and the software would auto-populate the model using the saved template. The geometry operations and all the logic, whichever we have inputted in the parent template, are filled in quickly. You just enter the new parameter values like updated dimensions, etc., and you're ready to check the design. Now, this saves massive amount of time, as I've already mentioned, especially for repeated join types like beam to column or splice connections. Now, as an additional note, the parametric logic behind the scene remains locked. So, unless and until you want to work with the old way of working with the templates, you can choose to explore the template for full editing. So you can work with the old style of connection design. Now, the second reason to use parametric template, it has the in-window parameter editing. Now, here is what IdeaStatica really makes it easier. Once a parameter or the template is applied, there is no need to jump back into developer mode and re-edit it again. Everything that's meant to be adjustable, like dimensions or spacing, everything that shows up right in the design tab, you simply type in the new values, the values that you have in your hand, and the model responds immediately. And you can see the bolts move, plates resize, every real-time feedback. You could see that now without needing to rerun or reload anything. We don't have to remodel anything. And also at the same time, while you're free to edit the parameters, the main logic of the connection stays protected, which you have created. And you can't accidentally delete wells operations or break the intended design. So if you're part of a larger team, whether you are a senior or a junior engineer, you know what exactly you're allowed to change in the project, and what are the upper and the lower limits to a certain parameter. This for you would be more like just filling out a form. And the third reason to use parameters would be there is bulk updates across the entities. Now, what you see on the left is the parameter linking process inside the IdeaStatic application. Now, at the top, we have defined a parameter that's for flange thickness, and below that, we are linking this parameter to a specific model property. Now, in this case, the thickness of the plate operation. So, what happens now is this: anytime we change the FTH parameter value, every operation or component that's connected to that value would automatically respond, provided we have the link or we have already integrated them together using proper expressions on the background. Now, that could include the well size, the bolt group, the stiffener positioning, etc. Now, this setup means that you don't have to manually coordinate each of those elements. They are all um, very intelligently tied to the parameter that you control. Now, you'll also notice that there is a create button there. Now, that confirms the mapping, the linking mapping. Now, once this is done, the relationship is built into the template logic. And here, the key point is that this reduces the manual work and makes the whole design process much more faster, much more simpler, especially for complex joints where changes affect multiple parts of the connection. So that could be easily tackled with parametric templates. Now, to the big question: how to use parametric templates. Now, we have seen how to incorporate this in the design workflow. We have seen that what are the steps involved in the design. But let me just take you through the sequence of how it exactly works inside the software. Like, how do we tell the software that these are the parameters that this and this is to be linked with this. Now this again can be modified to three stages. The first stage is to input the sources, that we begin with identifying the parameters. Now, which are the parameters that are available for user modification? How we want to modify. There usually can be two types of inputs in a parametric templates: user input, which is the base input. Uh, the inputs that the user actively select, like flange thickness, bolt count, etc. Now then there is the model property. Now these come from existing geometry of the model, like cross section or dimension of any material property. And the first stage, as I mentioned, is to identify those inputs. So these inputs are nothing but those values which all other inputs rely on. Now the second stage is the expression evaluation, or that's the creation of the expression. Now this is where the logic happens. A bit of math is required in here, not a lot of math, but a bit of math. So as you know, an expression that considers one or more of the parameters, that is either only the user input or the model property or both of it. Now, for an example, let's say you want a plate length to always be 1.5 times the flange width of the same. You would define an expression like length is equal to plate length into 1.5, wherein you bring in both the user and model property. Now, this logic is completely evaluated dynamically. That is, if the flange size changes, the plate length automatically updates. Now, to create these expressions, if you're wondering how exactly to create those, there are a number of applications to create that, like CalcPad to write the expressions, or you can also use the Excel sheet for that. Idea Statica itself in the web page, they have the guide, expression guide, which is also available. I think Venki would be saying a bit more on that. And the third stage of the output, the property, is that now we have created the expression. The result of that expression is now stored in a new parameter or intermediate parameter. I could call it parameter 3, P3. Now that value can be either used to create a new logic or further create a new logic, or can be pushed back to the model as a new property. And that's how the entire process inside the software works. Now, I quite know that you might be a bit confused about the theoretical part. Now, to clear all your confusions, I'd like to bring in Venki here, who would be demonstrating us what exactly I have just mentioned. So, Venki, are you here with us?
Yes, Rose.
Right, the stage is yours.
Yes, thank you. Thank you for detailed presentation on how to work with parametric templates. Let me share my screen. Rose, can you confirm that you can see my screen?
Yes.
Okay, great. Thank you. So I'll walk you through how you can create the parametric templates and how to work with them. And for our example, for our demo, we are considering this model, a beam framing into the column, a simple shear connection with a simple fin plate. And we will see how to control the plate thickness parametrically, and also to specify the limits of plate thickness, like maybe you don't want plate thickness be less than 10 or greater than 20 some limits, upper and lower limits, and how to set that limits and how to verify them, whether your connection fall in that limits, and to control the number of bolt rows and bolt columns, and adjust the plate dimensions automatically by uh, the number of bolts change, and on standard spacings. Like we have the standard spacings, like the standard edge distance 1.5 times, and the standard pitch, which is 2.5 times minimum, but recommended is 3 times. So based on that spacings, we will try to adjust the plate automatically. And this is a simple model which will be used to just demonstrate how you can get started with the parametric templates. So let's go to the model. So the same model was represented here, and with the same fin plate. So initially, to get started, first you have to go to the project and go to preferences, and there will be a developer mode option here at the bottom. You have to make sure that you switched on this option. Once it's switched on, uh, you will have 6 tabs instead of regular 5 tabs, which is the developer tab, in which you can create your parametric templates. So let's go to the developer tab. Our goal was to create a parametric template for the fin plate so that it can be applied to any beam and adjust it with just a few clicks. So let's get started with the parametric templates. Uh, Let me extend this. So this is a parameter UI in which you can do all the expressions on calculations and everything, but don't expect that just once you enter the parameter, the model will be updated, because this is the calculation zone where you have to refer that respective parameter to the model object. Then only the objects will get changed. Let's see a simple example, like how to control the plate thickness. To get started, in the parameter tab, you will have a plus symbol, which will add a new parameter row. The first one was the parameter ID, based on which we will be using in subsequent ones. So the ID, you can name it as per your requirement, not necessarily it has to follow a flow. So uh, for this example, I will give some ideas th, uh, description, uh, uh, a bit detailed, like fin plate thickness, and expression is, this can be a constant or a variable in the form of an expression. Uh, we have a web link to get access to various expressions, how to use them in this to create your own parametric templates. I will show that a website as well. Let's go with this. Here, as of now, I'm going to give a constant value, not a expression for now. And all the units are in parametric templates are in meters. So ensure that it was well converted into in your calculations to ensure you have proper conversion. And the next value is the output of the expression which was specified here. So if you give an expression, it will calculate and it will give you a result here, and we'll be seeing that in the next parameters how it does. And value type is defining the what type of value is this. So in this case, it's not generic, it's a thickness value which should be represented in In such a case, go to value type, scroll it down, and change it to plate thickness. You will find a lot of options, and choose the respective one for your respective parameter. In this case, it's a plate thickness. I will give plate thickness. So here you can see I specified here in meters, and it is converted to 10 And the next one is the visible option. What this does is, like, once you switch it on, your parameter will be exposed so that you can make changes. Um, if you go back to the design tab, in the operations, you can see I just entered this parameter which got exposed. But if you change the values of the plate thickness, it won't be updated in the model. This is because there is no link formed between the parameter which I just specified in the developer tab and the model object. So you have to ensure that the respective parameters which you're creating should be linked to the respective model object, like the plate or bolt, weld, anything, or even the loads as well. So let's link it. To link it, there is an option on top which says add new model property link. You can click that, and once you click it, you will have access to all the model objects which were there in the model will be visible here. So in this case, the plate is shp1. So I will expand this shp1 operation and select the thickness, because this parameter corresponds to thickness of the plate. It is to control the thickness of plate. Therefore, I have to go to the property of that operation and select the respective parameter to control it. And I'll create it. So if you go to the next tab, you will see a link is formed between the model property, which is SHP1. You can see at the bottom the SHP1 shear plate with 10 thick. A thickness parameter, model parameter, is formed linked with the my defined parameter, which is TH. Now, if we go back to the design tab, in the operations, now if you change, the plate changes. As you can see, I'll increase more for visibility, or 100. So uh, generally the working in IDStatica with the parameters like this, you have to define the parameters and link it with the model objects, model properties, then only the parameters will work. So fine, let's proceed with the next steps. And in this model, I want to restrict the plate thickness as well. Like to do that, I can go to this the three dot option, and we will have limitations like lower bound and upper bound. Here I can specify the minimum plate thickness, like maybe 0.006, means 6 mm. You can't model a plate it's less than 6 mm. That's what I'm saying here uh, in this parameter option. And I want to give in this example a maximum of 25 thick for the plate. So my lower limit is 6 thick and upper limit is 25 thick. If I model something less than 6 thick, or if I model anything more than 25 thick, I will get an error. So validation is passed, so it is okay. I will press OK. Again, we'll go back to the model design, and in the operations, I will try to change the plate thickness to 5 mm, where my lower bound value is 6 mm. So now you can see a warning. It says the defined value, which is 5 mm, which is lower than lower bound value 6 mm, which I specified. And similarly for the greater thickness as well, if I go to like 26 mm, it crosses a upper bound value of 25 mm, and so on. So like this, you can specify the limits to restrict users to have a set of plate thicknesses. One more way to restrict the plates was as an expression. Like here, I have specified the constants like 6 mm and 25 mm, but in reality, maybe we will be considering the plate thickness is equals to the web thickness of the member which is connected, and maybe restricting it to not greater than 2 times of member web thickness. So if you want to define that as an expression, then I need the web thickness, actual web thickness, which is a variable. So to get that, I will create new parameter, and I will name it. I mean, there is no restriction for this. You can name anything uh, for this cross section, beam thickness of web, and description. I can name it uh, very clearly so that I will have reference to it, quick reference. And for this, I have to use an expression to get the thickness of this web to the value. To uh, if you are getting started and you don't know how to start with these expressions, there is a reference guide at the bottom. Just click on it. Once you click on it, you will have access to this website in which how to use the expressions, and all the details were there. So you can uh, like, let's find how to get the member web thickness in this page. So I scroll down, member related cross section property function, in which web thickness is defined here. And the example input is I have to specify like get beam plate thickness of uh, the respective cross section and the web. So I will just copy it, and I will go to the expression. I will just paste it and ensure that the respective member web for which you are calling is the same name as this. Here I specified B, and the name of the beam is also B. If it is something else, change the name accordingly and press enter. So I have calculated the value. I mean, like, I have retained the value from the model to the parameters, and this is uh, a unit which is of with mm. It's not a generic equation, so I will change it to length component. So here I can see 6.6 mm. If you go to the web thickness at the bottom, you can see it's 6.6, which is the same. So I defined my web thickness with this. So now I will go back to the limitations which I set for the thickness, which are constants. I will change it to don't give any plate thicknesses which is less than the member web thickness, and upper bound I will give it as like don't give any plate thicknesses which is greater than twice the thickness of web of that beam. So this how you can define it with equations, and you can also input constants as required. So now uh, as a reference, like the web thickness is 6.6 mm. So if in the operations I change it to even 6, so you will get a warning similarly. And let's go back to the developer tab, and oh sorry, I will remove this. And these warnings are just to intimate you, and it won't interrupt your analysis, or it won't cause anything. Like this is just an information for you, saying that your plate thickness falling lower or higher than your specified limits. That's all. And I will change it back to 10 mm. Let's continue with the other parameters. So the next thing to control this finite operation was to control the offset or setback here, the gap between this column and the beam. So I will add a parameter for that, and I will name it offset, and I will name, sorry, offset, and the description as beam offset or setback, or whatever is convenient for you, you can specify it. And specify a constant 0.01, and I will change the value type to length component, which is 10 mm. By default, you can also put restrictions for this, going to this like don't give any setbacks less than 10 mm, or don't give more than 20 mm. Similarly, how we just seen for the plate thickness, you can do that. And let's continue with adding all the parameters. Then we'll link with the model properties, and we will see how the parametric template works. So I will continue with the parameters. The next one was to create the plate offset from member top, to control that. So I will add a top, and do remember this id should not be with spaces. Like if you want to specify space, provide an underscore like this, so that you won't have any errors. In the description you can give spaces, and they are no problem. Like the name is plate top offset, and I will give a constant which is 25 mm, and I will change the component to length, just 25 mm. However, in IDStatica, to define the reduction in the plate from top flange, we have to give as a minus 25, not as positive 25. So I want to change this value to minus 25. To do that, I will add one more parameter, which is uh, maybe I will name it as mtop, and I will leave it as this. For the just negative conversion, so I will put minus of previous parameter. Like in the previous parameter, I have defined this 25 mm as an offset from the top flange, but I wanted in only in the negative sign, so I'm just doing negative of top, and you can see it is converted to negative, and we can leave it as this. Go to the next parameter, which will be the number of rows. I can name it as mm, number of bolt rows, and number will be a whole number, no units, so it's not a generic. I will go to the whole number with which has no units, and I will copy the same parameter and change it to nc, which is number of bolt columns, and I will give the number of columns as 2, and it is whole number again. And I will add one more parameter to define the edge distances and spacings. Now it is edge distances. For that, I will give maybe R1, and I will specify it is bolt edge distance. And uh, one more thing here, we want to control the plate entirely, the length and width parametrically. So here, let's see how to control it based on minimum spacings or minimum edge distances specified in the code. Like for the edge distances, we have 1.5 times of die of bolt, as Rose specified in her just mentioned that you can do the equations in this. So let's just go with the expression, which is 1.5 times of dia of bolt. So I will just specify the expression like that. So I have a warning here which says that parameter dia is not defined. Yes, so nowhere I defined the diameter. So for the diameter, which is the diameter of the bolt, I have to get the diameter of the bolt from the model. So I will hold this here. I will add a new parameter with the name dia, and this is bolt diameter. And for that, uh, I will go back to the uh, reference guide, and I will go for that bolt equation what to use. Like I can search bolt. Here we have the expression for get bolt diameter, how to use it. And an example input was also given, like get bolt diameter of the plate element. And so I'll copy this and go back to the expression. I will paste it. However, the plate name is SHP1 here. It's not FP1. So I will just change the name of the plate, which is SHP1. So I got my diameter of the bolt. I will just specify as 24 mm. As you can see in the model, it's 24 mm. So I recall now. So now this will be calculated exactly, and I will change it to the length component, which is 36 mm. So for 24 dia, which is multiplied by 1.5, gives 36 mm. So we'll proceed with the next parameter, which is spacing. For that, I will use RS, and it is bolt spacing. It might be a pitch or a gauge. And as per the code, minimum requirement is 2.5. However, recommended is 3 times of diameter of bolt. So we will model it as 3 times of the diameter of bolt, which is 3 star die of the bolt. So, and I will change the generic equation to length component, which is 72 mm, 24 multiplied by 3, which gives 72. You can also choose to round off the value to next highest value. Like for example, if you have 72, if you don't want 72 for your bolt spacing, you can round it to 75 as well. You can do that as well, but I'm not doing that in this demonstration. Let's proceed further. RS and C1, which is the spacing of the first bolt. I mean the edge at here, which is this. So in this case, I'm considering all the edge distance as same, so which will be represented by R1. So I will specify first column location, and I will refer the same parameter which I have defined earlier, which is R1 for bolt edge distance. If you want different edge distance, like calculation of like 2 times of dia or 1.75 times, you can specify that accordingly. And coming to the next parameter, which is uh, TED, which is transverse edge distance. This is to calculate the length of plate and in both longitudinal direction and transverse direction. So let's see how to calculate TED. I will not specify any parameter. I can specify transverse edge distance. To calculate the transverse edge distance, I will specify the expression, which is concat of R1. Here I can see the generic equation. I will leave it as is because we are not going to expose this. It's an hidden calculation. So I don't mind what are the units are. However, if you want, you can change it from generic equation to any of the uh, other things based on the parameter defined. So I will go with the other parameters, which is the spacing in the transverse direction. I will name it R spacing, which will be transverse spacing of poles. For this, I will give an equation uh, like this, which is nothing but concat of RS, which is nothing but the bolt spacing multiplied by the number of bolts minus 1, which is the pitch distance. If you have 3 bolts, you have 2 pitches. So 2 times multiplied by that edge distance will give you the spacing of in transverse direction. So that's what this equation is. So we got the result. Then we'll go with longitudinal edge distance. I'll leave it, and I can use the concat equation again, and I will change instead of R1, I will specify it as C1 because I'm getting this distance. Next, I will copy this and I will calculate the spacing in longitudinal direction. So longitudinal spacing. So I'll specify C, SPA, and I will change the equation accordingly to NC minus 1, and I can get the result. So we have defined all the parameters here. So let's start linking and let's see what are the parameters which I want to have a control over without coming to the developer tab. The thickness, yes, I need a control over it, and the offset of the beam, it should be visible, and the plate top offset to control the offset of the plate. And I also need information about number of rows and number of columns. However, I don't need the control for the edge distance or the spacings here because I'm automatically controlling it with 1.5 times of dia, which is a standard recommendation by the code. Even the bolt spacings, which is 3 dia, it's standard recommendation as a code. So I don't need to expose these values to change anything. It's an automatic calculation. So let's go to the more. Okay, let's link it with the model properties. So first one, I will link it with the offset. I will go to this option here to link the model property. I will go to SHP1. You can see the setback was given with the gap value in the operations. So select that and create it. And the next one was the top control, which is this negative value. Again, link it with the operation, which is top, create, and I have to link the transfer search distance. To link it again, I will go to here and SHP1. I will scroll down and go for the active cases of transverse edge distance and create it, and which is spacing. I will go to the next SPHP1, scroll down, see the active case of transfer spacing and create it. And this is longitudinal spacing. Similar way, you can go to the SHP1 and go for the longitudinal edge distance, create it, and this is longitudinal spacing. Similarly, we can go to the same operation and go to the respective model property and link it with our parameters. So once you link it, you will get its used switch on. So our parametric model is completed. We have already linked all the properties with the parameters. Now let's see how we can use it. I will go to the design tab. Uh, to see the parameters, I you can click on the operations, which says P, which means it's parametric. So all the parameters which are exposed are here, which is 10 plate thickness, beam offset, plate top offset, number of bolts, and number of columns, so on. These are the exposed options. I'm not exposing any other parameters to edit. So if you want to do it in any other models, you can go to connection library and publish this template and name it as per your requirement, and keep the type of connection, whether it's moment connection or shear connection or a truss connection, and choose the library set where you want to add, whether you alone want the access to this parametric template, choose personal, or all the colleagues from your team wants to work, then you can choose company set. For now I'll go with the personal, and switch on this option because we are publishing a parametric template. So to this is to filter out the templates based on parametric option. So you can click on publish. So it will take a couple of seconds to publish it to your personal set or company set. I can close, done. So if you have any new connections, like without the operation set, like the blank models, you don't have to start from scratch. Like since we already published the template, I can go to the propose option. Um, with not only the templates which we published, but StatiCa already offers a lot of parametric templates. You can try to explore them. But to see how our template works, which we created now, I can go to the template which I posted and press OK. And if it is in different codes, it will ask for equivalent conversions. You press OK. And so the template is applied. Your time.
It seems that we lost Venkatesh due to some connection issues. Uh, so I will take over. Uh, Basically, what Venkatesh just wanted to finish uh, was the display of applying the parametric template on the connection that you have, and with just that you designed that are allowed in the template, you just model the connection as you desire, and you're good to go. Thank you. You're back.
Sorry about that. Okay, sorry about that. Back. So let's see how the parametric template which we created works. So I can go to the operations to see all the parametric options which I've exposed, and control it by spacing. Maybe if you want 3 columns of bolts, just change it, and the plate will be automatically adjusted based on the 1.5 times of its distance, and the spacing will be 3 times of uh, die of the bolt. And hence if I change the bolt dia to something else, then the plate dimensions will be automatically adjusted, and I can like increase the number of bolts and even offset the plate. So if I have a new connection, like maybe instead of this I have HA200 beam, then if I apply this template, then it's in a few clicks edit. Like I will press 2 bolts, 2 columns, and I will increase the die of the bolt to maybe 24, and it's done. So, and maybe it's 25, and it's done. So it is as easy as this to work with the parametric templates. And the spacings and edge distances for 24 dia is different, and uh, for so 20 dia is different, 60/30, and for the any other bowls is different because we gave expressions to calculate and automatically make that changes in the model. So this is how you can easily play with parametric templates to get the most out of it. So and I have a similar case to show you, which is this example. This is just a use case for you. I'm not going to talk about how to create parameters and how to link it with the model. This is just a use case, like maybe the homework for you. You can go through the control the gusset automatically instead of in the previous example we control the fin plate. In this case we can control the gusset automatically based on the inclination of this diagonal. uh, I will go to the operations. I will change the angle from 30 degree. So you can see that gusset shape as well as the end plate and all the bolts will be adjusted purely based on the diagonal angle, 35 and 40 and 45 and so on. So this is one of the time taking tasks to modify the gusset shape based on your inclinations. So with the parametric template you can just parameterize and use the connection as required. So as simple as that. So let me share my presentation back. We just covered the demo, and let's see some of the best practices and a default control set. uh, if you are starting with the parametric templates, start small, maybe with a few parameters, and then you can explore it to very big parameters, because initially if you start with a lot of parameters, you might get overwhelmed. That's why it's better to start with small and then move gradually. And don't expose all the options which you are parameterizing, and whichever not required you can hide it in the developer tab. No need to expose, because if you expose too many options, then it might overwhelm you, assuming that it's too many options like that. So only the options which need to be changed, that only keep it as visible, and rest of them as hidden background calculations. And leave as a default control sets like welds auto sizing, which was available in StatiCa, and a bowl class plate materials for the best advantage you can get from the Statica. And some of the common pitfalls, like if you have too many exposed parameters, you might get overwhelmed. That's why only expose the essential parameters and hide what the automated parameters. No need to expose them. And the naming of the templates which you are publishing into the connection library, make sure you have a unique name for your published template, so that you won't get confused with two different templates. And also, if you're creating a parametric template from scratch, make sure that you do the validations from the extremes to ensure that the parametric template which you have created performs well in all the situations. So that's it from me. Uh, Back to you, Jan.
Thank you, Vicky. Wonderful demonstration, even wonderful tips and tricks. I will wrap up the session with some summary slides. Actually, I really think you even done the summary well uh, when you displayed how the parametric templates can be applied thanks to the proposed feature, and how easily, thanks to just a few parameters, you can get to the model that you require. There was a very good question by Kasif at the beginning of the session. What is the actual difference between parametric template and the regular template in Idea Statica? Yeah? Uh, both of them obviously are much faster than starting from a scratch. However, if you're doing a repetitive designs, the parametric templates, it's much faster. And this is what you nicely displayed, Venki. And I even have this. Had this uh, thought process this week, thanks to one blog post that was published on Idea StatiCa webpage. You can find it on Idea StatiCa blog, and it was a report from something like a competition that where 6 teams was involved, and Idea Statica was observing. So those 6 teams got the same assignment. Uh, So design this nice connection during the workshop. There are some specifics you need to follow. I sections together with the hollow sections. They are loaded horizontally by wind, etc., etc. And what was interesting uh, was that there were 6 designed in the end, each of them compliant with the requirements and with the codes. However, each of them was completely different. Yes, you could, of course, if you would go into the detail, some of them were a bit more optimized, some of them had better process in between. But if you think about how so many designs can be applied on one assignment, one job, you will find out that there's actually never one right solution. If you're experienced engineer, uh, you always get to the right solution, and this is actually something what it's your job. This is what you're being paid for. Uh, but the question here is, if you actually need to do all of the heavy lifting by yourself, by designing from the scratch. Uh, uh, with Venki, we compared this comparison how it can look when you when you start from the scratch, and you have a project with 50 braced joints, something what Venki displayed on the second example. And so if you have 50 of them, uh, each of them is same type but needs to be adjusted. So if you model either from a scratch, even with a template, it would take you on average 25 minutes on to do each. So the total here would be somewhere around 20 hours. However, if you focus on the productivity and you want to tackle this task as fast as you can, uh, thanks to the parametric templates, you can significantly slice the design time by up to 80% on average. So the as I said at the beginning, yeah, the thinking here is considering whether the creativity that you're putting into the design is in this particular case bringing any value. Of course, and by no means we try to tell you that you should not be creative, you should not create the connections from the scratch. Of course not. But instead of doing it all the time, think about applying it on the ones that really have a value. Yeah, some super complex, very difficult, or somewhat specific, and on the everyday connections or slightly moderate connections. Yeah, why not to bring in the parametric template? So that's how the parametric templates can bring change in your engineering lives. So that would be a wrap up of this session. Just to thank you for being the participants on the first session on our summer educational series. There's more ahead of us. There's 12 sessions in total that you can apply to. Actually, it's not 100% true anymore, because our workshops that we have at the beginning of August were booked out in the first 30 minutes. So yeah, the limited seats, because they are hands-on, we're going fast. But there are still free spots. There are still free spots on our onboardings, on our trainings, and on additional webinar on that we will do in Ask Me Anything type of way. So feel free to register. Registration is still open, and you will find the registration on our GSD Idea webpage on a section of training and consulting services. The last, and to kind of give it a call to action also to the parametric templates, if training is not the best way you would like to move forward. In GSD Idea, we're dedicated to make sure that you leverage the investment in Idea StatiCa as much as you could. So as part of our consulting services, there are two ways how we can help you kick off the parametric templates in your company, in your team. One of them is that you send us your connection or connections. We will assess them, let you know what would it take to set up the parametric templates for you, and we will actually do the parametrics templates for you as part of the paid service. So if you want to have it hassle-free, just come to the ready-made templates. We can support you in that. If you would like to go the learning journey, learning way, we can do a mix, something what we call the workshop-like approach. It's very similar. You send us one or two templates. Again, we will assess them, but we let you watch. You can look how Venki or Rose create those parameters and learn on the way. So the first one or two we do for you, and you learn on the way, and the next ones are on you, and we can provide feedback. So that's how you can bring those parametric templates alive in your teams and companies. Ladies and gentlemen, that's it from us. Thank you very much for being with us. And now we will be closing officially the session, and we will be answering the questions in the chat panel, if there are any. So thank you very much, and see you on the next summer educational session of GSD Idea. Goodbye.